Good morning, good afternoon, good evening, and welcome to another edition of Red Hat Advanced Cluster Management Presents. I am Chris Short, executive producer of OpenShift TV here, and I am joined by a bevy of Rackham team members. And Scott, I will rely on you to do the round of intros this time.
Chris, we always appreciate jumping on your show. I'm sorry.
You do bring the thunder, yeah.
I've tried to bring the thunder, no pain, no gain. But, through what are we in season 1 of Rackham Presents? Is this, are we calling it season 1?
Yeah.
We have had a chance to introduce various characters, and the plot has thickened. I think we're getting some peaks and valleys as we take the experience through. There's no breaker of change yet. We haven't quite reached like the dragon phase, but anyway, metaphors aside, I'm excited to bring more of our team to meet you and to meet the world and talk about what we're doing with multi-cluster management. I'm going to turn to my left, which I don't know where that ends up on people's screens. How about Gurney goes first for the intro?
On the stream, it's nowhere.
Oh, yeah, there you go. Can do. I'll hop in, Scott. Thanks. I'm Gurney Buchanan. I'm from the CI/CD /DevOps /tools /whatever gets thrown our way squad. So we do about it all, and whenever Scott needs to spin up some more AWS resources, he hollers our way. So
when I want to spend cash, I talk to Gurney.
Yeah, and they nicknamed me Mr. Pool as well after the last stream about cluster pools. So that did happen.
One thing Gurney doesn't do is hang out at an actual pool, but if it's a CI/CD cluster pool, he's in. He's all in.
Too cold.
Nice. Then we turn it over to Dale down there in my bottom left corner.
All right. My name is Dale Heidesek. I'm a developer with the GRC squad. It's the little govern risk tab in advanced cluster management.
Not so little. It's kind of a big deal. Governance, risk, and compliance.
That's a big deal.
Shouldn't undersell.
No, don't ever undersell that.
And then Kevin from the sunny skies of Toronto.
Hi, everyone. I'm Kevin Cormier. I work on the application lifecycle squad, particularly on the UI side.
Awesome. So we've got DevOps, we've got GRC, we've got app. This is actually the trifecta. When I talk with customers,
this is the trident, right? Yeah.
You're trying to bring these cultures together. We actually are going to try to do that today. It might be oil and water in some cases, but we have some really cool stuff teed up. A lot of this centers around the value statement of Rackham being your cluster management interface, your central plane for the universe. And one of the key pieces that we rely on in there, as we've discussed in the past, is Hive. And the Hive API being that centralized layer that we drive all of our OpenShift goodness through so that we can drive it on cloud or on-prem or wherever you're hanging out with your clusters. Hive is part of that message. So Hive API, I'll drop a link in the chat when I get back to that window. Thank you. And that's a place for you to hang out upstream and start learning about what we're doing with multi-cluster and how we're driving a single API experience there. Then when you do that, you find out that you've got cluster sprawl, right? All of a sudden you're spinning up clusters rapidly, and maybe you're not paying attention to the budget and the billing. And when you get to the end of the month, you realize you've just spent $10,000 on a cloud that you didn't expect to. And that was actually what Gurney, he doesn't actually have these wake up moments. He has these shower moments. I'll let him describe how that works. But he had this showering moment where he's like, we're spending all this money, but we could use something called cluster pools. And we can really start to centralize our costs and start to bring down things with Hibernate. So it all kind of started to come together. We pitched it early with you guys a couple of months ago, and we're coming back for another round of it that goes deeper and wider and farther in between. So take that cluster as cattle concept, take that cluster driven experience with Hive, understand cost, and that kind of sets the table for what Rackham is going to solve today. And with that, I will turn it to Gurney to drive into the first area here with cluster pools.
Sounds good. Thanks, Scott. Yeah, Scott was referencing the usual. I think the subreddit that I find a good home in is shower thoughts, because most of the time.
Oh, that is a good one.
Yeah. I sent my tech lead a message at admittedly 3 a.m. Last Saturday morning and said, I've had an idea. Also ignore that it's 3 a.m. So it's one of those. So I'll go ahead and grab the screen share and just share my little we're just going to be pretty much 100% shell 100% of the time today. Well, at least for me, and I think the other folks as well, they may show some UI. So I guess the quick intro on cluster pools for those that didn't hear me blather about it last time and haven't heard me talk about it for the past 6 months, all of my coworkers, bless them, is that we have a I guess at first we had a CI/CD scale problem. So we are, utility that lets you manage, or a piece of software that lets you manage a bunch of different OpenShift clusters and some Splat.ks clusters on all of these different cloud platforms. And of course, when we're going to ship and say, hey, customer, we support this, we're going to test it. So we need a lot of clusters, and we do CI every 2 hours or so. We do a new pass for all of our maintenance releases. So we're looking at like, hey, we need like 15, 20, 25 clusters. We need that to shrink and scale if we want it to be cost effective. So as we started looking at, hey, wait, we ship functionality to help with this. So what if we start using some of the Hive bits that they ship? So the big thing that we settled on is cluster pools. So what Hive lets you do is you can say, hey, I want to make a cluster deployment, and my cluster deployment is just me making some YAML that tells you how to make a cluster. And I want it to look like this, and it'll go off and it'll make your OpenShift cluster for you. And say, here's your cluster, here's your credentials, all those details. A cluster pool lets you say, hey, I want you to make 5 clusters that look like this, and I want to be able to check one out and then say, I want to use it, and then hand it back and say, I'm done with this. And you go clean it up and replace it, have another one ready and waiting there for me. So that's what we arrived at as a really good solution to this problem. I'll go in a couple more of the details, and the other folks will as well, of where this really gets powerful. But to start off with, I will just go ahead and do a quick OC-get cluster pool in our, we're going to be doing a Twitch demo namespace on this OpenShift cluster today. So hopefully this will, I haven't tried this in a little bit. There we go. So we have one cluster pool out there. So this is a great way to just kind of give the quick 5-minute, here's what a cluster pool is. We have a cluster pool named Twitch Demo 470. It's running on this base domain, and it's running on this OpenShift image. So this is just saying, hey, I want OpenShift 4.7, just came out, all the shiny new bells and whistles. And I want there to be 4 of them at all times. Make sure there's 4. And right now it says, hey, you have 4 ready, already waiting out there. Now we'll make something later called a cluster claim that is you saying, hey, I'd like one of those 4. So we can do OC-get cluster claim and see that I cheated and went ahead and made 2. So these are cluster claims that are just literally point directly to an OpenShift cluster that we can poke around at in a bit. Those are full OpenShift clusters. The moment we go and delete these Kubernetes objects, it'll go clean up those clusters. So everything's managed as kube objects. Even your Kubernetes clusters are kube objects, and the recursion is not lost on me, because we'll have some fun with that. So the first thing that I'll show off here is just the process of making a cluster pool. So last time I came on the show, bored everyone with a ton of YAML. I just pull up YAML files, I edited them, and I OC applied them. And I know that's like watching paint dry. Well, this time we have a project called Lifeguard, which makes life a lot easier. I did make a terrible pun in the README up near the top. I should have did a head on that. But yeah, we make a terrible pun that this is just something to keep you from drowning in the cluster pools. Yeah, here we are, keeping you safe in the cluster pools.
Womp womp.
Yeah, we make far too many puns, and you'll get more later today. So it's just a bundle of bash scripts that I wrote in an afternoon, and now everyone has started adopting, and Dale keeps making PRs into because I have typos everywhere. In these bash scripts, and it just exposes some real simple capabilities in an open source project. I don't know if Scott wants to drop the link in the chat, but we'll go ahead and make ourselves a new cluster pool. So it's as simple as going into this cluster pool directory and then seeing, hey, yeah, oh, Gurney, I see that you already have your one set of YAML sitting here. We'll ignore that. So we can go ahead and it's just a bunch of scripts that let you run through and apply. And it says, hey, yeah, you're on this cluster. Here's your namespaces you can put a cluster pool in. So we're going to go into Twitch demo and say, hey, yeah, we want to put it there. We're going to go ahead and toss it on AWS. And it says, hey, here are the secret names that you have sitting out there. So remember, I did this ahead of time. We don't have to create any secrets on a live stream. So there's my credentials. There is an OpenShift pool secret, and we just say, go point at those. Let's also make this one an OpenShift 4.7 cluster pool. So we'll just go ahead and snag that image set that just tells it what type of cluster to put up. We'll put this in AWS region US East 1, where I have some space for this. Tell it to use our super special, super secret domain. We only want one cluster here. I don't think that we'll be using this. So you can put any number of clusters to keep kind of Little Caesars hot and ready style for checkout. Yeah, and we'll just call this Twitch doing it live, as I mistyped it live.
Yeah.
And it just applies. It'll tell you, hey, here's the YAML I applied. If you want to be boring and snoop, you can look at the YAML. It just applied that YAML, and now if we do an OC get cluster pool, we'll just see that, hey, we have a new cluster pool, and we can go investigate if we really wanted to and see that it's running a nice little pod off in the background in a different namespace to provision one cluster for us. And that little bit will flip to 1 whenever we have a cluster. So as that's off in provisioning, we already have our other cluster pool ready to do some checking out. So we can go over here and just go into cluster claims. And this is just, once again, a little utility that lets you create, delete, grab your creds from, and reconcile your cluster claims. So we'll go ahead and just apply real quick. And this will run through and do a little bit more fanciness in a nice little script. Namely, we'll want to grab it from the Twitch demo namespace. It'll say, hey, you have these, only one of them has it ready. We'll go ahead and grab a cluster from that. We'll do Gurnben live claim, and it'll ask us. So this is the number, the first feature that I can kind of talk about. So you can set a lifetime on a claim. So this is incredibly good for CI scenarios where I know our job takes a maximum of 8 hours, for example. So I'll set this number to say, hey, I only want this cluster to live for 8 hours. And after 8 hours, no matter what, it will go in and reconcile and tear down these resources so we don't get charged. There's no risk that your CI is going to leak a bunch of expensive resources because you'll always have this to clean it up. We then can associate it with an RBAC group. In this case, sure, let's associate it with our RBAC group so that everyone knows that us Twitch demoers do indeed own it. And then what it's going to do, and this is the number 2 really cool thing that I absolutely love about cluster pools and has saved us so much money, is when a cluster is sitting in that pool counting, hey, we have 4 ready. It's actually hibernated, and it's Hive hibernation. I call it hibernated. It hasn't caught on.
Hibernated.
So,
you heard it here. You heard it here first.
Yeah, still haven't gotten it to catch on, but basically it shuts down the VMs. It's your usual, have you tried unplugging it after the day is over to save on your electricity bill? Mm-hmm. It shuts down the VMs, and then whenever you check out the cluster, what it's doing right now is it says, hey, I've claimed a cluster. It's still resuming. So all those VMs in AWS are literally changing their power state to running. And then it's going to make sure it can connect to the cluster. So in about 5 minutes here, we're going to get a cluster that we can actually reach and log into and poke around with. And it's a full OpenShift cluster. And in the release we're about to punt out the door, we're actually going to have the ability to customize these clusters. So you can say, hey, I want bigger workers or smaller workers or more or less workers. All of that sort of configuration that you normally get in the OpenShift installer is going to be here too. All of these functions will kind of work. So I've babbled on about this for a little while and said, hey, we have all these cool pools, and you can grab clusters at some crazy scale. Other cool things, you can scale the pools up and down in size. These are all just kind of OC operations. You can just apply some YAML, do an OC get, pull for the status of these Kubernetes objects. And that's all well and good. And we have a little tool that makes it easier. But then we kind of just threw these ideas and said, hey, we're using them. Devs, why don't you guys go have a heyday with this? We can save some money if you guys do it and hibernate. So that's where Dale and Kevin come in. So I'll go ahead and give an intro on these folks. Dale and Kevin are both awesome guys. I sat next to Dale in the before times when we were still in the office in RTP. And he said, hey, these are really cool. And I think I can make my life a whole lot easier, not having to like manage having clusters everywhere and provisioning them and deprovisioning them and forgetting where they are. And, oops, I broke the cluster. I now need to spend a half hour fixing it. So they've built some really cool tools.
So a developer needs a cluster, developer spins it up, developer owns that lifecycle, put the tools in the people's hands and let them party. But also make sure it doesn't drift, right? Yep. That right. Lifetime of it says, I don't want a cluster that's just hanging out in the corner collecting dust and CVEs. Mm-hmm. So you got to pre-bake in that security posture too.
Yep. It's an automated lifecycle management. I'll admit that I've left expensive clusters up over the weekend because 5 o'clock on Friday rolls around and it's like, it's board game night. I'm gone. So I have other obligations. So it's like, I forgot to turn on that cluster and that cost the company $500 this weekend. We've all done it. Yeah. Whoops. So
some clusters don't cost that cheap.
Oh yeah, you're completely right. These are dev tests. We're cost optimizing. It's stuff like that in their development environments. And the other problem that we encountered with our developers, and I don't know if anyone else developing on OpenShift has ever had this problem. I'm sure they totally haven't. Where you accidentally run something in a deploy of something, and you make a huge mess on your cluster. You've screwed up your dev test environment. You accidentally installed 4 operators in the wrong namespace with the wrong configuration. And you can uninstall them, but there might be some resources sitting around.
Some finalizers you'll probably have to delete. And yep. Yeah, there's a bunch of stuff going on there. Yeah.
And we had, I recall where it's like, oh man, my dev cluster screwed up. It's going to take me 2 hours to get this thing back. So that's kind of the other problem that we said, hey, maybe this will solve that because you can kind of just throw it in the garbage bin and ask for another one. Is the really cool one. So I think at this point, my best next step is to hand it off to, I believe Dale's taken over after me, and he's going to show a lot of the workflow sort of stuff for, hey, here's all the cool stuff I built to use this tool, and I will go ahead and stop screen sharing while this checks out our cluster.
Nice.
Oh, by the way, Gurney, hibernated.com is available if you want to go buy it.
Oh, okay. I should probably go do that real quick.
Yeah.
All that cash he's saving on his cloud bills.
Right.
All right, Dale, take it away.
All right. So here we have an empty terminal. Let me just hop on over. All right. So like Gurney said, he came to us and said, hey guys, you need to save a couple bucks. Because it was messy. It was like kids in a candy store. They were like, here's AWS, guys. It's open season. Do whatever you want with it. So we each had our own cluster. It was great, but they came back and said, oh, you guys have spent a lot of money. We need to rein it back. So then Gurney says, we have these cluster pools, and we go, well, that's great, but we're not saving any time. Like if we have this cluster just ready to go, then it's just sitting there. Like we can just get to it right away. So like there was a concern with getting to Rackham as quickly as possible. And so that's where my solutions came in. So Gurney built up Lifeguard. And that was a great way to lower the bar to cluster pools. And then I came up with a script. I called it Start Rackham, that encapsulates Lifeguard and our deployment scripts so that you can just one-stop shop, run a script, and it would like claim a cluster and then also deploy Rackham with the configurations we need for development. So that was my story.
You're basically tying together the cluster pool with our application. Ours is called Rackham, but Johnny developer has something called Pac-Man, and they would basically tie together these two things and script it out so they have a nice, clean, quick way to have their development app up and running every day.
Nice.
Ooh, so what have we here?
Yeah, so we're gonna crank up Visual Web Terminal. We're gonna bring the terminal into Rackham and try to interact with it here as much as we can, because we are being hosted. Like all these clusters are made available because of Rackham. So right now I'm not in my demo namespace, so I'm gonna switch over. The Twitch demo. All right, so now we're where I want to be. And so before I start talking about Start Rackham, I wanted to crank up this job. So I containerized, what I did is I created an image that would containerize the Start Rackham script. And so that we could have that development cluster that we don't really care about, don't really have to maintain. If it gets broken, it's fine. We get a new one the next day. And it only deploys Monday through Friday. It has a lifetime that, as Gurney described. So it deletes itself at the end of the day. So we don't even have to think about cleaning it up, which is really nice.
You took out a bunch of guesswork for your team too. You basically centralized one way to do it and said,
oh yeah.
You said, folks, I'm going to alleviate burdens that you would normally run to and waste time, because your squad of 10 developers no longer has to spin up their individual clusters, face those ad hoc headaches that they get with infrastructure or code changes or some script that they're keeping on their desktop, to make it all work.
Right.
So, yeah, this is like real DevOps, real GitOps, real dev-driven need and solution. Love it.
Awesome.
So we'll just create it and let it run while we talk.
And Rackham Stackham, I know, Chris, you wanted that moniker months ago.
Yeah, no, Rackham and Stackham is my thing, man.
Yeah, I said, well, that makes me think we're going to be spending our days in the data center. I want to run away from that topic.
Well, no, we can reinvent the term.
There
right?
it is. There it is.
Right? Like that's what we're doing. You want all these clusters racked up, rack them and stack them with this. Here you go.
Love it.
So here's the Start Rackham script running inside the container. So it needs to know where it actually, if you run and Start Rackham locally, it needs to know where your lifeguard repo is. We have a private repo currently, called Pipeline, where we store all of our tags and things. And then the deploy repo, which is open, and that's the scripts to install Rackham. And so you can see it grabbing those and then starting up. And then here is where it enters into Lifeguard and claims a cluster. You can see it has a 12-hour claim. And it also populates with our RBAC group so we can get to it once it actually deploys. We'll let that run. And we'll talk about Start Rackham a little bit. So like I said, we wanted a quick way to get to Rackham, but we also needed a lot of configuration. We needed to be able to get to any version. We need to get to upstream. We need to get down to downstream. Right now, those processes are a little bit complicated because we have to, because we're working on being open. Like it's an urgent thing, but we're nearly there, but not
pretty
quite.
close. Probably like a couple of weeks away from being
really
open source.
okay,
Yeah.
cool.
Totally, yeah. There's a huge push, even in this next 2 weeks. So
Awesome.
So it can claim any branch, version, or snapshot that you want. So if you, by default, it'll just get the latest one, which is usually what we need if we're trying to verify bugs. That was like the biggest hang up. We'd have to constantly update clusters. So now every morning we get the latest the latest upstream snapshot on a cluster. But if you give it a branch, you can give it 2.0, and it'll give you the latest Z stream. So it'll give you 204 or 208. I'm not sure where we are right now, but if it doesn't have enough space, it'll resize the pool automatically. You can tell it to. You can also, so we do development from localhost. We run our component locally, and then so the cluster needs to be able to communicate through OAuth and accept those connections. So it'll patch those if you want it to.
Nice.
And then it will also it pulls configurations from a script. So it does all the exports inside of this config script. And you can see all the cluster, the lifeguard exports, the Rackham exports. And then the nice thing about that is that I'm able to like create variables dynamically. And if I need to adjust anything, I just come into the script and change it, and then run the script, and I'm off to the races. So let's move over to, let's see, we're still claiming over here. It usually takes about 10 minutes. So in total to get to Rackham. So we'll hop over to our containerized script. So it's a cron job. I created my own image that pulls in all of our repos, and then you feed it you feed it secrets, and you also feed it a Slack URL or Slack token, and that lets you post the credentials when it deploys. And then if you give it a Slack token and channel ID, Slack now allows you to create a scheduled message. So it scheduled a message to pop up 20 minutes before the cluster is set to expire. So you can get in there and extend it if you need to, if you happen to be working with it.
User experience, I love it.
Yeah,
driving the team into Slack and getting them all going there.
Yeah, that was actually my team. They were like, hey, it'd be really nice to know when this thing is disappearing.
Isn't that funny how it works? You think you've got it all figured out, but no, it turns out in an open environment with good decision making, you can foster these kind of things on the fly. You can build it and contribute. This is the Red Hat way, so to speak.
Yeah, no kidding. So then we also, the other thing we did is we set up some RBAC users so that if you need to, you can go in and see what the view looks like as like a view user or an edit user. That's something we had set up in our development environments.
There's something new about that, because I don't remember that being around when we looked at this back in, was it November timeframe? So what's the new story around RBAC?
Yeah. So I think what Dale, I think you're showing here is you're making these RBAC users in the cluster you check out, right?
That's correct.
Yeah. So I guess to go to your question, Scott, there's actually in the new version of ACM, which is the newer version of Hive, we started using cluster pools a lot and found a couple RBAC scenarios that were like, hey, this would be really nice. So now it's set up where when you claim a cluster, you can associate it, and this has already been like this. You can associate that claim with, an RBAC group or a user, or some owner or list of owners, and they'll all be able to access that cluster. So if you and your squad have like an RBAC group that has some permission on your hub cluster, you can check out a cluster and say, all of these folks own this cluster. So everyone that's in that group can read and access your cluster. In the same way now, Hive is letting you, and ACM is letting you associate a group or a user as a cluster pool owner. So they also get to see all the resources associated with the cluster pool. so they can see like the inner workings of it's provisioning 3 new clusters because it's out of clusters, that sort of detail that it's doing. They can kind of pull back the covers and see, and that's a Hive cluster pool admin. So that's going to be GA sometime this week, hopefully, where that capability in ACM, where you can say, hey, this person's the cluster pool owner, they should be able to see all the special behind the scenes. So that's going to be a really cool one too for that RBAC story. And that may be a good follow-up as well, Scott, because we're working on, I know Tim, one of my tech leads, is working on a really good RBAC story around automatically configuring RBAC on these clusters that you check out.
Nice.
Yeah,
that's awesome. And that solves a huge security gap that we don't want to put this out there without having thought through. And it's awesome to see the enterprise controls coming into Hive more and more.
Yep.
Sweet. Dale, where are we at with that Rackham and Stackham?
Yeah, so in the background, you can see it just finished. Right here is our deployment. It's deploying the latest snapshot that it could find. And you can see it deploying. And right now, it looks like it wrapped up right here. So there's our URL that we'll meet later. And right now it's waiting. It looks for the ingress. So it's waiting for the ingress to come up because even after the deployment, the pods are reconciling and still installing. And so
stabilizing. Yeah.
So
run that back. You just deployed the 2.3 build. I mean, you're blowing my mind because that branch was just cut like what, last week or something?
Right.
And so we can quickly spin out dev test clusters for that without even a heavy lift. You're already just targeting that new snapshot.
Right. Yeah. This is from yesterday. So.
Yeah, and we have basically a unified deploy methodology for our dev stuff between our CI and our developers. What our developers are using is these dev tools now. So this is even something, especially with like the app model in Rackham, you could do for your team, where you say, hey, here's a dev tool that we use for CI behind on our meta level, and we use to deploy the stuff that also you as a developer can run this image and just use.
Nice.
Yeah, that's awesome. That's nice.
Yeah. So let's see. Where was I? So real quick, here's the message that our team gets from Slack from the bot. So it just gives us the RBAC users, and the password is generated randomly. Gives us what snapshot we're looking at, its lifetime, and when it was created. So the lifetime is from the creation point. And then other credentials in the URL. And then 20 minutes before, it'll tell you, I'm about to go away. You have 20 minutes.
Nice. That's helpful.
Dale, I think you accidentally made OpenShift's cluster bot, which is in Slack, and you ask for clusters. I think you accidentally made a pool-based version of ClusterBot, so that's really cool.
I know. I was thinking it'd be really cool to be able to interact with the bot and say, like, give me a cluster.
Right.
We'll see. That's.
I like where this is headed.
I know.
I do too.
Yeah.
All kinds of ways to spend more money when you're not intending to.
Yeah, totally.
Or when you do intend to.
It asks you to enter a credit card number whenever you ask for a cluster, Scott. That's the setting.
It's Craig's PayPal account, right?
Yeah. It's bless our Craig. We joke about he's the money man, but he handles all the billing stuff. Bless him.
So since that's been claimed, so we should be able to hop over to Lifeguard and look at the cluster claims. Go to the cluster claims directory and do a reconcile claims. And that what that'll do, so full disclosure, I wrote this script. It will look at the directories, because each claim gets put in its own directory, whether it gets created or not, just so you can see the YAML and you can try again if you mess something up but it's small, or if it was successful, then the credentials will go in there. And so what this will do is it'll grab all the claims that are remote. It'll wipe away all the local ones that are no longer relevant, and it'll pull in all the remote ones and update them. So I can go into this one And then we have our credential files here, and I think I'll be able to show them, but because we're going to delete this after this, but we'll still let's copy the password for now. All right. All right, let's see how we're doing. Oh, and this is stopped. So here we are. It patched the ingress with all of our local host connections, all the paths that I wanted, because our team is responsible for a couple different things. So there's a couple different paths that we want it to have. And then here it is creating our users. So it just uses a quick HT password and instantiates the RBAC users, and it should be ready to go. So let's go back up and get to our URL.
So you're in a shell within a cluster pool within a Rackham.
Yeah,
within a
like
virtual shell.
Where in the inception script are we?
I think we're somewhere flying through the air on our back while the van.
Right, there you go. Exactly. The special effects have kicked in.
Let's see. Looks like not everything's up quite yet, since I can't get to I can't quite get to the Rackham console yet. But we do have a kubeconfig file in here. So this is a handy command I use all the time to get to it.
Hey, by the way, Dale, the newest build of Rackham may not install the whole way. This is the in-dev one. We've only had a week to bake this one.
Yeah, so that's the other risk with getting the latest, is that sometimes it doesn't actually work for whatever reason, because it is like bleeding edge. You never know what's in there. So it looks like we're getting there.
Still spinning up. Things are happening.
Yeah, yeah.
That's awesome. So end to end, and then talk me through that cron job. Is it you're basically instructing this to happen every day for a 12-hour lease, I think is what you had on there, and then tear it down at the end of the day, do it again on Tuesday, and then only Monday through Friday. So you've ensured that there's guardrails to to the cost factor on this one.
Right. And only Monday through Friday. Let's close this out and see what we got. So there's this cron job. Yep. The 1 through 5 is Monday through Friday.
Nice.
If you know your cron job. It's never easy to interpret. And then we also have a cluster pool expand and shrink job. And those are hosted in Start Rackham also. If you want to go back and take a look under the extras folder. And so all those do is run a patch on every cluster pool in your namespace. And so that at night, our cluster pools are scaled down to 0. And during every morning, they're scaled back up to 1. So we have, like right now, we haven't migrated everyone over. So we literally have 0 cluster pool clusters running at night. And then with Start Rackham's ability to scale cluster pools dynamically, we don't need to have a large cluster pool running. We can just have one cluster. And then if someone claims one, half an hour later, another one pops up to be ready. And then if you run Start Rackham, it'll scale the pool automatically to 2 and grab that extra cluster. So
nice.
Yeah.
It makes a really nice AWS cost graph as the person who's supposed to look at all the cost graphs. There's also another Red Hat project they're working on called cost management. That's like a software as a servicey thing. And that makes for really nice graphs for each of the accounts, because you kind of get to see it do this and it's every 12 hours sort of thing.
Nice. So that's kind of what we get to look forward to, is the user experience of bringing pools, hibernation, cost management, bringing that under Rackham's purview, so that at the fleet level, you now have controls to say, hey, hibernate all these dev clusters on Fridays, or delete them if they're just dev clusters. we're going to be baking those controls into Rackham so that you have that sort of level of capability to drive it out there to the fleet. What they're doing on the CLI is great. I'm more of a UI guy, as you can tell. My chops in the CLI are lacking a bit. But the fact of the matter is, what we're building out, what we're generating this interest on your show, Chris, is to help define where do we go next year? How do you want this to look? Right?
Yeah.
Do you want to do a checkbox on all dev clusters and say hibernate them right now? Do you want to be able to scale those down to 3, shared master workers or single node clusters? Like, let's start thinking through how we really achieve that at a fleet capability. 1,000 clusters that we're managing, that kind of stuff.
Yeah.
Yeah.
And bringing in Ansible, which should be coming up anytime, is going to be even more powerful, because like really my script should be Ansible. Like it should be like waiting and checking to see that resources exist and then continuing. And it might even make it run faster for all I know. So
nice.
Yeah, that'd be awesome.
And once you have all this kind of codified, all these best practices codified for, Dale, he can just kind of use this tool that's been provided to him by the, whatever infrastructure provider you have at said company. For us, it's the CI/CD team kind of says, here's your cloud account. We have one shared cluster that everyone has access to, and he can just put up pools and use this and know that he's going to just conveniently have a cluster there when he needs it. And whatever he does, it'll be about as cost effective as it can be within reason. So if you can kind of codify these best practices in a way that everyone can just so easily do the most cost effective and easiest thing and secure thing, that's really great, because it takes a lot of weight off of like me checking the bill every month and saying, hey guys, you left a bunch of clusters running.
Left the lights on.
Yeah, exactly.
Whoops.
It makes it really easy to codify it.
So, Kevin, take me through some of that user experience. If anybody has spent time in the ACM console, they understand what a buttery experience that is and how smooth it is. And a lot of that comes to the eye and the articulation of Kevin. And I want to hear, what are we looking forward to? Tell me a little bit more about what you've been working on and this project called Cluster Keeper, I think is that the right name?
Yep.
Awesome.
So we won't be looking at UI a whole lot. This is a CLI-based tool that I came up with, much the same as Dale. Gurney came knocking and said, hey, why don't you take a look and see if your squad can maybe spend less money on your cloud costs. So I thought, cluster pools and hibernation are really interesting ideas. We want to start using them. But I did recognize that there was going to be some overhead in using these in our day-to-day activities. So for example, in this terminal, I have my OC targeting that shared cluster where our cluster pools are set up. So if I look at the deployments, cluster deployments, specifically the ones for this demo, you'll see their names, they have these auto-generated bits at the end, right? 5 characters, and that's even in the URLs for these clusters. So they're very, these names are hard to recognize, hard to memorize. And then as you get into using cluster pools, you're probably going to be recycling your clusters more often. So on top of that, these names are changing all the time. And anytime you need to manage the power state or the life cycle of these clusters, you need to target your OC or your coup control back to that, I call it the cluster pool host. So the cluster where all those cluster pools and cluster claims and cluster deployments are defined. So I created this CLI called Cluster Keeper to try and deal with some of those issues. So that was the cluster deployments. If we look at just get the cluster claims, by default, we just get the names of the claims. If you actually wanted to see the actual cluster deployment, you would need to maybe look at the YAML output for that, for example. So the first cluster keeper command I'll show you then is list. You can say claims, cluster claims, claims. I usually use CC, so it recognizes a bunch of aliases. And I'm not going to go over the configuration really, but basically all I had to tell Cluster Keeper was the server URL for this cluster pool host, the namespace that our cluster pools and claims are in, and that RBAC group name so that my squad members can also access the same stuff. Basically, then once you run it the first time, it's going to walk you through logging into the cluster pool host. So anyway, that is all set up. So if I run my list cluster claims, I get this display where I can see the actual cluster deployment that's associated with the claim. I can see its power state, whether it's running, resuming, hibernating. I can see the lifetime. So Gurney set a lifetime of 8 hours on the one he created at the beginning, and Dale's lives for 12 hours. We have the age column here, so you can do the math and see how much time you have left. So that's collecting kind of all the relevant information for you so that you don't have to go through and find the associated cluster claim, cluster deployment or cluster pool.
And these are YAML attributes, but you'd be sitting there with JSON output or YAML output sorted through JQ pipe sort this blah 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 cut. Yeah,
exactly. And yeah, like none of these things are difficult to do. It's just time consuming if you're doing them day after day.
Right.
Switching clusters. So, and my OC was already targeting this cluster pool host, but the nice thing about the CK CLI is that anytime it needs to access the cluster pool host, it has created a context in your kube config. So, right, so normally I could say OC context, OC config current context, and that's CK. So the CK context is the context it has created when it talks to the cluster pool host. I also have a short form because I don't like typing that long string. So CK current tells me I'm pointing to the cluster pool host. So this is probably my most used command, right? Because I'm frequently checking, what is the power state of the clusters I need to use? Are we using more clusters than we should be, etc. So then if we talk about when I want to actually use one of these clusters. So if I didn't have Cluster Keeper, as I mentioned, I would have to target my OC to the cluster pool host. Then I could use Lifeguard. So I think Dale pointed out the get credentials script. I could run that to get the credentials. That's going to create a directory associated with that cluster that has a kube file. It has a OC login script if I want to use password-based login. So I would have to use one of those methods to connect. And then maybe I would, there's also a credentials file if I want the console URL. So I wanted to kind of get that down into one step for Cluster Keeper. So the idea is that everything is keyed by the cluster claim name. So on my team, we're using very simple names for our cluster claims. So I might, rather than having like a numbered claim, I might just call it prototype or demo or dev, something like that. And so I mentioned that CK list is probably my most used. The most useful would be CK use. So if I want to use, say, this cluster here, that's actually going to switch my kubeconfig context to point to this cluster. So for example, let me run some OC command to show that we're on this cluster, right?
So quiet. And he's typing it all correctly. Oh my God.
I really should have copied and pasted that. But on OpenShift clusters, we have this infrastructure resource called cluster that has various information. So here we see
cluster info. We'll give you that too, actually. Cluster-info.
Oh, okay. Well, I'll try that later. But as you can see here, the URL matches the cluster deployment name, that TSSCH. So I want to show you, this one I've used before. So I want to show you if I try to use claim number 2, what actually happens behind the scenes. So CKUs intentionally switches your kubeconfig context to use that cluster. But all other CK commands try to not mess with your current context at all. But what happens when you use something like this for the first time, you'll see it's creating context. It fetches those credentials automatically, prepares the kubeconfig. There's a little bit of fiddling that it does with that. Creates a service account so that you're not constantly having to log in. You have a reliable session. And then it actually backs up your personal kubeconfig file before updating it to add the new context for this cluster claim, and it switches you. So Cluster Keeper is all centered around kind of these contexts for cluster claims. So now that my current context is claim number 2, I can use commands like cluster claim console, and I don't have to give the name of the cluster here. So it will infer that for my current context. So what that will do is open. So it actually copies the kubeadmin password to the clipboard, and it opens this in the console. So these aren't set up with a proper certificate, right? So I'm going to get this warning.
Should get 2 of those. Here we are.
Yeah.
Make sure you're alive. Really makes you earn it.
So here I can just type in kubeadmin. That's not too hard to type, and the password's already on my clipboard for me. And there's our console.
Nice.
So I want to show you, there's a similar one for accessing ACM or Rackham. So this cluster that Dale created with Start Rackham, I haven't touched it yet. There's one small caveat here, which is Cluster Keeper uses service accounts. So I need to enable permission on that cluster to be accessed by service accounts. So I'm going to run that first. And then if I do ckacm, we should have our, we go through the same steps. Obviously creating the context, fetching those credentials. And eventually we should see the browser open a new tab and similarly copy the password for us. I'll have to go through the same cert stuff.
Nice. Now, let me ask you a question. How did you know that that cluster had ACM on it? Other than the fact that we've been sitting here watching Dale work with it.
Yeah, that's just by convention. The tool does look up the route for ACM from the cluster. So if it doesn't have ACM, this will fail.
Okay, that's fair.
That's good.
Yeah.
Like, yeah.
You want that?
If I accidentally do something, if I point like a command at the wrong cluster, I want it to know, right? Like, don't just randomly start installing CRDs and crazy stuff. Like, tell me, nope, no ACM available.
Right. So I mentioned that it usually tries not to change your context. So say you're working with one of these clusters, someone asks you, hey, can you run this other task on this other cluster? So whoops, this used to be called CM. So my fingers still sometimes type CM instead of CK. So there's a similar command called CK with, and that takes the name of it. Whoops, that was the password there. Sorry about that. We will be deleting these clusters after anyway. So say I was using claim 2, so my OC is targeted on claim 2 and I don't want to change it. I'm busy doing something, but I want to run something against claim 1. So I can use my cluster keeper with command. So that will extract the kube config for this cluster here to a temporary file, set the kube config variable environment variable, and then run this script so that you can carry on with your regularly scheduled programming.
Nice. That's handy.
And what I usually use this for actually is for working with the cluster pool host. So some of the things I haven't added in Cluster Keeper are working with the cluster pools. So Dale has the cron jobs to automatically scale the cluster pool size up and down. So I haven't adopted that yet. So on my team, mostly we've been just keeping that at 0 clusters ready because we haven't been creating new clusters all that often. But you can use CK with, so for example, I think I'm probably done with the browser. I'm going to make my window a little bigger here. So remember, CK is that special context for the cluster pool host. So then I can say, I can run a regular OC command to edit, say, the cluster pool, which was what? Twitch demo 470.
Am I reading that right? CK with CK. Wow. Okay.
Yeah.
So the inception thing comes back to haunt me.
Yes.
Yeah. So this is just if you didn't want to change your current context, and you could, come down here, edit your size, for example.
That's cool, though. I like it.
No, you can also say use CK, and now your context is CK, and then you can run your OC commands against the cluster pool host.
Gotcha. So you're editing the cluster pool sizing and parameters that Gurney showed us at the beginning of the session today, where he said, I've got these 4 things already queued up.
Yep.
Nice.
So the other bits that I've added, I think it's okay if I hibernate any of these clusters, right?
Especially the one that you just exposed the password to, yes.
Yeah.
Demo claim 2 is gone now, so it doesn't exist anymore.
Real time
I've cleaned both of them up already with shameless plug Lifeguard.
Wow.
So there's a hibernate if you want to manually hibernate a cluster. If I look at the list of clusters now, we'll see that cluster is stopping.
Nice.
You have, of course, the. I'm going to switch to use. Well, that's probably not. Yeah, it's gonna.
Mm-hmm.
So Cluster Keeper tries to help you out and do a lot of things automatically, right? So if you try to use CK with, use CK console, CK ACM, it's going to wake up that cluster. So that cluster was already stopping. The other thing it's going to, so this hibernating and running is done by editing the power state, spec.power state on the cluster deployment. So I have gotten into some problems with Hive sometimes if one of these operations was in progress and I was too eager and I changed the state again. So another thing Cluster Keeper does is it checks for that. So if I try to run this cluster while it's in the process of stopping, and it might already be stopped, but yeah, so it's waiting up to 15 minutes for it to actually be in hibernating state, and then it will restart it. How much time we got? We're running close to time.
Yeah, you can run a little over if you need to, though. Don't worry.
We're on the edge of our seats, Kevin. Keep it coming.
So that was manual running and hibernating. So I did want to mention that on my team, we are using another project called Hibernate cron job. And Cluster Keeper is designed to work well with Hibernate cron job. So I think this might have been presented before on this show, but basically it just helps you set up some Kubernetes cron jobs that say at like 6 p.m. every day will hibernate all your clusters. So that's what this schedule column is all about in this list display. So if I wanted to turn on scheduled hibernation for this cluster, I enable schedule. And then we will see schedule is true. And that hibernate cron job, it looks at a hibernate label on the cluster deployment for whether it should operate on that cluster or not. So because this one now has the schedule enabled, that is set to true. If the schedule was, if I then disabled scheduled hibernation, this would be set to skip to tell that cron job not to operate on this cluster. So actually, yeah. So, and then the other aspect, yeah, that I wanted to mention is locks. So this locks column, on my team, we share a lot of our clusters. So we do have them scheduled to go to hibernate every day at 6 p.m., but obviously sometimes that's not realistic. Somebody needs to keep working later than 6 p.m. So there's a lock feature. So I can say, lock that cluster. And that works by putting an annotation on the cluster claim.
Nice.
So it tells you, it uses my username by default. And even though this cluster normally participates in scheduled hibernation, currently that's being skipped because of the lock. What this also does is other cluster keeper commands will warn users that this cluster is locked. So it's hibernating now. If I try to run it, it says, can't operate, it's locked by me. Use -F to force if you really need to. And the other thing you can do is you can put any old string in for the locks. So we've actually integrated this with our build system. So our build system can wake up the cluster that it needs to use for testing purposes. It can lock it with a unique ID on the build. And then we see that lock is in the list. When it's finished with that cluster, what it does is it will run, if it's during normal off hours, so after 6 p.m. or on a weekend, it will run the CK hibernate command, but it doesn't add the -F. So that way, if any other build jobs have the cluster locked, then it doesn't actually get hibernated.
Awesome. This is starting to inform us, right? Like these use cases are how we want to build out that user interface, that sexy experience for how we drive these things at scale. And yeah. these are exactly the types of scenarios you'd run into where someone's trying to claim, but it's already in use, or someone's trying to run, but it's in the hibernate mode or going into hibernate mode. And so, yeah, my mind is just getting excited. I hope that the community is ready to tap in and play. Open-cluster-management, of course, is where you want to hang out, or the new hibernated.com URL, which should take you there. Newly minted. Good job. Hopefully it's cascaded to all the DNS servers across the globe.
Yeah, you might have to refresh your DNS cache a little bit, but other than that, it should work.
We're ready to rock. Yeah, Kevin, I didn't mean to cut you off, but this has been great. Anything else?
No worries. Well, there's a whole list of subcommands here, so I didn't go through them all. There is a shortcut for creating a new cluster quickly. It's just, it runs through Lifeguard. It uses Lifeguard. It just speeds it up a little bit so you can type one line and then go.
Nice.
Awesome.
Super fun set of tools and resources. I hope we've met the level of expectations that you've put on us, Chris. We always have fun on your show. Thanks for having us back.
No, thank you for coming back, right? Like, you all do such an amazing job of putting the right people on the call, doing the right things. So I appreciate all your behind the scenes work, and definitely the fact that all this is being done out in the open. And this is going to help not just one company. This is going to help lots of people.
Yeah. We're having fun too. And these are projects that come out of the demand that we find in-house, and we think other teams are probably suffering these same challenges, across the globe. So come play with us in Open Cluster Management. We do meet on Thursdays for the community call, and you'll be able to find that at the Open Cluster Management site.
Awesome. All right. Well, thank you all so much for joining me today. Thank everybody for watching out there. Good turnout for the show. Lots of repos dropped. So go dive into that code base and check out, what you should or should not be using potentially for your cluster. Yeah, until next time, thank you all so much. Appreciate it.
Thank you, Chris.
Stay safe out there, everybody.
See you.
Thank you.